Yes, the understanding of the code is correct. Regarding the first question, the calculations are correct. For 9 number 12 NM cables in a 2-inch hole, the adjusted ampacity is 21 amps, which can be landed on a 20 amp breaker. The same would hold true for a number 14 wire with an adjusted ampacity of 17.5 amps. Now let's delve deeper into the National Electrical Code, or NEC, specifically focusing on the ampacity derating of non-metallic, or NM, cables and the rules pertaining to conduit fill. The NEC addresses these factors to ensure electrical safety and prevent overheating of conductors, which could lead to insulation damage or even fires. When multiple current-carrying conductors are bundled together, as is the case when running several NM cables through a single hole or conduit, the heat generated by each conductor can raise the overall temperature within the bundle. This increased temperature reduces the ability of the conductors to dissipate heat, effectively lowering their ampacity. Ampacity refers to the maximum current, in amps, that a conductor can carry continuously under specific conditions of use without exceeding its temperature rating. The NEC provides tables and adjustment factors to account for this derating. Table 310.15b3 in the NEC, specifically the 2017 edition, provides adjustment factors for the ampacity of conductors in a raceway or cable with more than 3 current-carrying conductors. These factors are applied to the allowable ampacity of the conductors as listed in Table 310.16, which provides ampacity values for various conductor sizes and insulation types. For example, if you have 9 current-carrying conductors in a raceway or cable, the adjustment factor is 70%. This means that the ampacity of each conductor must be reduced to 70% of its value as listed in Table 310.16. In the specific scenario of 9 number 12 NM cables in a 2-inch hole, first determine the ampacity of a number 12 conductor with type NM insulation. According to Table 310.16, the ampacity of a number 12 copper conductor with type NM insulation, operating at its 90°C rating, is 30 amps. However, due to the presence of 9 current-carrying conductors, apply the adjustment factor of 70%. This results in an adjusted ampacity of 30 amps multiplied by 0.7T, which equals 21 amps. Since the adjusted ampacity is 21 amps, you can safely land a number 12 wire on a 20 amp circuit breaker. This is because the breaker will trip if the current exceeds 20 amps, protecting the conductor from overheating. The same principle applies to a number 14 wire. According to Table 310.16, the ampacity of a number 14 copper conductor with type NM insulation, operating at its 90°C rating, is 25 amps. Applying the same adjustment factor of 70% for 9 current-carrying conductors, the adjusted ampacity is 25 amps multiplied by 0.7T, which equals 17.5 amps. Therefore, a number 14 wire with 9 current-carrying conductors can be safely landed on a 15 amp circuit breaker. Now, let's address the second question regarding running 20 NM cables in a 2-inch PVC pipe. According to Section 310.15b3, adjustment factors must be applied when the number of current-carrying conductors in a raceway or cable exceeds 3. However, Exception 3 of this section states that adjustment factors do not apply to conductors in surface-mounted raceways or cable trays where the conductors have specific spacing requirements. In the scenario of running 20 NM cables in a 2-inch PVC pipe, the adjustment factors would typically apply. However, Exception 3 provides an allowance if the cables are adequately spaced and secured within the service panel. This exception recognizes that in certain situations, the heat dissipation of conductors in a raceway can be sufficient to mitigate the need for ampacity adjustment. However, it is crucial to ensure that the NM cables are properly secured and spaced within the service panel to promote adequate heat dissipation. The specific requirements for securing and spacing NM cables within the service panel are outlined in other sections of the NEC, such as Section 312.5c, which addresses the bending, space, and arrangement of conductors in enclosures. Furthermore, it's important to consider the local code official's interpretation of the NEC. The code official has the authority to require additional safety measures, such as sealing the 20-inch nipple with fire stop material. Firestop material is used to prevent the spread of fire and smoke through openings in walls and floors. If the code official requires the use of firestop, it would effectively eliminate the exception provided in section 310.15b3 because the firestop material would impede heat dissipation. In that case, ampacity adjustment factors would need to be applied. Therefore, the determination of whether or not the scenario of running 20 nm cables in a 2-inch PVC pipe is code compliant depends on several factors, including the specific requirements of the NEC, the interpretation of the local code official, and the proper installation and securing of the cables within the service panel. Now, let's break down the key sections of the National Electrical Code, or NEC, related to NM cable ampacity and conduit fill, elaborating on their specific requirements and how they apply to various scenarios. We'll focus on the NEC 2017 edition, but keep in mind that local codes may adopt different editions or amendments, so it's always best to consult with local authorities. Firstly, Table 310.16 provides the allowable ampacities of insulated conductors rated up to and including 2000 volts, 60 degrees Celsius through 90 degrees Celsius, in free air and in raceways. This table is the foundation for determining the ampacity of conductors based on their size, insulation type, and temperature rating. For NM cables, which typically have a temperature rating of 90 degrees Celsius, use the 90 degrees Celsius column in Table 310.16 to determine the initial ampacity before any adjustments. Secondly, Section 334.80 specifically addresses ampacity for NM, or non-metallic sheath cables. This section states that the ampacity of NM cable shall be in accordance with 310.15. The allowable ampacity shall not exceed that of a 60 degrees Celsius rated conductor. This is very important. While NM cable insulation is rated 90 degrees Celsius, the NEC limits its use to that of a 60 degrees Celsius rated conductor for ampacity purposes. This section also includes requirements for protecting NM cables from physical damage, such as installing them in conduit or using cable trays. Thirdly, Section 310.15b3 provides adjustment factors for the ampacity of conductors in a raceway or cable with more than 3 current carrying conductors. This section is crucial when multiple NM cables are run together in a conduit or through a single hole, as it requires the ampacity of each conductor to be reduced based on the number of current carrying conductors present. The adjustment factors are provided in a table, and they range from 80% to 40%, depending on the number of conductors. Remember that neutral conductors are generally not considered current carrying conductors unless they carry a significant amount of harmonic current. This is an important distinction when applying the adjustment factors. Fourthly, exception number 3 to 310.15b3 states that no adjustment factor shall be required where conductors are installed in surface-mounted raceways that have a cover and are arranged so that the conductors are running side by side and the height of the raceway does not exceed the width of the raceway, or where conductors are installed in cable trays in accordance with section 392. This exception provides relief from the ampacity adjustment requirements in specific situations where the conductors are adequately spaced and ventilated. The exception recognizes that in certain installations the heat dissipation of the conductors is sufficient to mitigate the need for ampacity derating. Fifthly, section 310.15b2 provides correction factors for ambient temperature. If the ambient temperature around the conductors exceeds 30 degrees Celsius, or 86 degrees Fahrenheit, a correction factor must be applied to the ampacity of the conductors. The correction factors are provided in a table, and they vary based on the insulation type and temperature rating of the conductors. This section is important in situations where the NM cables are installed in hot environments, such as attics or near heat-generating equipment. Sixthly, Section 312.5c addresses the bending space and arrangement of conductors and enclosures, such as service panels. This section specifies the minimum bending space required for conductors entering and exiting enclosures, as well as the proper arrangement of conductors to prevent overcrowding and ensure adequate heat dissipation. This section is particularly relevant when running multiple NM cables into a service panel, as it provides guidance on how to properly manage and terminate the cables. Seventh, Section 300.2 22 addresses wiring in ducts, plenums, and other spaces used for environmental air. This section restricts the types of wiring methods that can be installed in these spaces due to concerns about fire safety and the spread of smoke and toxic fumes. NM cables are generally not permitted in ducts or plenums used for environmental air unless they are specifically listed and marked for such use. 8th, local amendments. It's crucial to be aware of any local amendments to the NEC that may be in effect in the jurisdiction where the electrical work is being performed. Local amendments can modify or supplement the NEC requirements, and they often reflect local conditions or concerns. Always consult with local authorities to ensure compliance with all applicable codes and regulations. Now let's apply these NEC sections to some practical examples. Firstly, consider a scenario where 6 number 12 NM cables are run through a single 2-inch conduit. According to table 310.16, the ampacity of a number 12 copper conductor with type NM insulation operating at its 90°C rating is 30 amps. However, since there are 6 current carrying conductors in the conduit, we must apply the adjustment factor from table 310.15b3. For 6 current carrying conductors, the adjustment factor is 80%. Therefore, the adjusted ampacity is 30 amps multiplied by 0.80, which equals 24 amps. In this case, the number 12 conductors can be protected by a 20 amp circuit breaker. Secondly, consider a scenario where 10 number 14 NM cables are run through a hole in a wood stud. According to table 310.16, the ampacity of a number 14 copper conductor with type NM insulation operating at its 90°C rating is 25 amps. However, since there are 10 current carrying conductors bundled together, we must apply the adjustment factor from table 310.15b3. For 10 current carrying conductors, the adjustment factor is 50%. Therefore, the adjusted ampacity is 25 amps multiplied by 0.50, which equals 12.5 amps. In this case, the number of 14 conductors must be protected by a 15 amp circuit breaker. Thirdly, consider a scenario where 4 number 10 NM cables are run in a surface-mounted raceway with a cover, and the height of the raceway does not exceed the width of the raceway. In this case, exception number 3 to 310.15b3 applies, and no adjustment factor is required. Therefore, the ampacity of the number 10 conductors remains at 35 amps, as listed in table 310.16. It is important to note that these examples are simplified for illustrative purposes, and the specific requirements of the NEC should always be consulted for any electrical installation. It is also recommended to consult with a qualified electrician to ensure compliance with all applicable codes and regulations. In summary, understanding the NEC requirements for NM cable ampacity and conduit fill is crucial for ensuring electrical safety and preventing overheating of conductors. By carefully considering the number of current carrying conductors, ambient temperature, and other relevant factors, you can properly size conductors and circuit breakers to protect against electrical hazards.